Now comes the question, what if we don't know the equilibrium concentrations of all the substances in our mixture? And so before everything had been given to you, you simply plugged in values into your equilibrium expression. What if you're not given everything? What if instead you know the initial concentrations, but you don't know what the equilibrium concentrations are? So let's actually look at an example that allows us to figure that out. All right, so if we read this problem, it tells us that we start with 5.00 times 10 to the negative third moles of hydrogen, 1.00 times 10 to the negative second moles of iodine, and it's placed into a 5-liter container, and it's allowed to react in order to go to equilibrium. Now, the equilibrium mixture of HI, it tells us is 1.87 times 10 to the negative third. This should be molar because that's concentration. All right, and what it's asking us to do is to calculate the Kc. Well, here's the issue. Up until this point, we've been told the concentration for HI of I and H2 at equilibrium, and then we just plugged it into our equilibrium expression. But in this problem, we actually are only told the concentration of one of the substances of HI at equilibrium, but we're not told the concentration of H2 or I2 at equilibrium. So we need to determine that. And what we're going to be using for this problem is what we call ice charts. So I'm going to set up my ice chart because that's the first step that I need to complete. So I'm going to rewrite my equation, my reaction. And then I'm going to write here I, C, E. I stands for initial, so the initial concentration. C stands for the change that occurs in order to reach equilibrium, and E represents the equilibrium concentrations. And so what I need to do is I need to fill in my initial concentrations. Well, I know that I start with 5.00 times 10 to the negative third moles of hydrogen. I don't know the concentration. However, since I know that molarity equals my moles divided by my volume, I can calculate that really easily. I know that my number of moles for hydrogen is this, and I know that my volume is this. So all I need to do is take 5.00 times 10 to the negative third moles and divide it by 5.00 liters. So what I end up getting for my initial concentration of H2 is 1.00 times 10 to the negative third. Now I need to do the exact same thing for iodine. I know I have 1.00 times 10 to the negative second moles of iodine. I know that I have a volume of 5.00 liters. And so when I divide, I end up getting 2.00 times 10 to the negative third. I also know that since I start off with this amount of reactant and it doesn't tell me anything about how much product I start off with, I'm going to assume that I start off with no HI. So that's the concentration of HI. All right, so for changing, I know that HI is going to gain in concentration because it's going from 0 to a higher concentration at equilibrium, and I need to use the stoichiometry of this problem in order to determine how much of an increase in concentration occurs. Well, I know that for every 2 moles of HI that are produced, 1 mole of I and 1 mole of H2 are going to be consumed. So I'm going to just write this as plus 2x. Now for these guys, I know that they're going to decrease in concentration since HI is increasing in concentration. Therefore, the change is going to be minus x because it's a 1 to 2 relationship. And again here, this is going to be minus x. Okay, so I'm first actually going to solve for x. And the way that I can do that, I know that the equilibrium concentration of HI must be equal to 2x. Well, I actually already know the equilibrium concentration of HI. It's 1.87 times 10 to the negative third. So I can calculate my x. I know that 2x equals 1.87 times 10 to the negative third. Therefore, I know that my x must be equal to 9.35 times 10 to the negative fourth molar. And now, since I know my x, I can actually plug in this 9.35 times 10 to the negative fourth in for x. And I can calculate the equilibrium concentrations for hydrogen and iodide now. And so what I end up getting for the equilibrium concentration of hydrogen, I end up getting 6.5 times 10 to the negative fifth molar. The equilibrium concentration of iodine is going to be 1.07, making sure I stick with sig figs, times 10 to the negative third molar. And I already know that my equilibrium concentration of HI is 1.87 times 10 to the negative third molar. All right, so let's review what I've just done in the context of these steps. The first step I did, I set up the ice chart. Check. Next, I filled in / calculated the initial concentrations. I had to calculate the initial concentration of hydrogen and iodine, but I knew that the initial concentration of HI was 0. For the third step, it says fill in, calculate the change for the species that I know. Well, I knew that HI increased by 1.87 times 10 to the negative third. I kept that at the back of my mind, but I first completed number 4. I used stoichiometry to calculate the other changes. I knew that this would increase by plus 2x. I knew that this concentration would decrease by x, and this concentration would decrease by x. And therefore, knowing that the equilibrium concentration of HI would be 2x, I was able to calculate the x value. Therefore, I was able to calculate the equilibrium concentrations by subtracting. I did that right here when I got 6.5 times 10 to the negative fifth by subtracting these two. I got 1.07 by subtracting these two. And finally, my last step, which I still need to do, I need to use these values in order to calculate my Kc. Well, I know Kc equals the concentration of HI squared all over the concentration of H2 times the concentration of I2. So now I can just simply calculate my Kc. I'm going to plug in all the values I know. I know the concentration of HI is 1.87 times 10 to the negative third. I know that the concentration of H2 is 6.5 times 10 to the negative fifth. And I know that the concentration of I2 is 1.07 times 10 to the negative third. And so when I calculate this, what I end up getting for my Kc with the correct number of sig figs, I get 50.3. Okay. So this enabled us to determine the equilibrium concentrations for values that were unknown and therefore calculate Kc. Other problems, I could give you your Kc and then ask you to solve for the concentrations. And so in that case, rather than solving for Kc, you would be given your Kc, and then using simple algebra, you could figure out the value of x, right? Because this, instead of being this value, this concentration would just be 2.00 times 10 to the negative third minus x. You solve for x and then find your answer. So those are the two different ways that you can do it. You're going to get plenty of practice with that way of doing it and this way of doing it in class.